Ever try to make a smoothie, but you shove a whole raw carrot into the blender too fast? The blades jam, the motor whines, and you're left with a mess. Snapping an expensive cutting tool on a CNC machine happens exactly the same way. To stop that from happening, we need to understand the two basic ways things move inside the machine. First, think about the blades spinning in circles. In machining, we call that the cutting speed. It's simply how fast the sharp edge is rotating. But spinning blades don't do anything until they actually touch the food. The second motion is you physically pushing that carrot down into the blades. That pushing motion, how fast you force the material into the cutter, is called the feed rate. On a CNC machine, the part that actually spins the tool is called the spindle. It works just like the motor in your blender, spinning the cutter at a specific speed that we measure in revolutions per minute, or RPM. If you push that metal into the spinning tool too slowly, the sharp edges don't actually bite. They just rub against the surface. All that rubbing builds up intense friction and heat, leaving you with dull tools and a ruined, melted cut. On the flip side, if you push the metal in too fast, you overwhelm the tool. It tries to chew more than it can swallow. The machine starts to shudder, makes a horrible chattering sound, and before you know it, your expensive cutter snaps right in half. Finding the perfect feed rate isn't about guessing or going by feel. It's a specific, calculated sweet spot based on real physics. Hit that sweet spot and your job succeeds. Miss it and things break. Let's take this onto the actual shop floor. Most of the work you'll do falls into two broad categories, and we'll start with turning. Turning happens on a machine called a lathe. Instead of the tool spinning, the block of metal itself spins incredibly fast in place. The cutting tool stays totally still, just sliding forward in a straight line to peel away material. This animation shows a lathe in action. Because the metal is spinning, we measure our feed rate based on those spins. We use a unit called millimeters per revolution. Looking closely at the cylinder, you can see exactly what that means. Every time the metal makes one single complete spin, the cutting tool travels a tiny, specific distance horizontally. To figure out how fast to set the machine, we use a simple formula. Your overall feed rate equals the feed per revolution multiplied by how fast the metal is spinning, your RPM. Let's try it with a real example. Imagine you are cutting a steel shaft. Your tooling chart says the tool needs to move 0.20 millimeters per revolution, and your spindle is turning at 1500 RPM. You just multiply those two numbers together. 0.20 times 1500 gives you a final feed rate of 300 millimeters per minute. You punch that 300 into your control panel, and the machine takes care of the rest. No hoping, no crossing your fingers. Just a smooth, clean pet every single time. Now let's look at the other major operation, milling. The physics here are the exact opposite of the lathe. The block of metal sits completely still, clamped to a table, while the cutting tool spins rapidly and moves through it. Because the tool is moving across the table, we measure the feed rate in straight linear distance, usually millimeters per minute. In this diagram, you can see how a milling tool actually works. As it spins, each individual flute, or cutting edge, takes a tiny bite out of the metal. We call the size of that physical bite the feed per tooth, or the chip load. To calculate your feed rate for a mill, you take that feed per tooth, multiply it by your spindle RPM, and then multiply it by the total number of cutting edges on your tool. Say we're carving an aluminum bracket using an end mill, which is essentially a specialized bit that can cut sideways as well as straight down. In this case, our tool has 3 individual cutting edges. Our tooling chart tells us the specific tool needs a bite of 0.04 millimeters per tooth, and we want to run the spindle at 20,000 RPM. We multiply our 0.04 bite times 20,000 RPM times our 3 flutes. That gives us a target feed rate of 2,400 millimeters per minute. That 2,400 is exactly what you type into the machine. It ensures each tooth slices off the perfect amount of metal, protecting the cutter from breaking while keeping your machining efficient and consistent. When you first see these formulas written out, they can look pretty intimidating, but as you just saw, once you actually use them, it's really just basic multiplication. Being able to do this math puts you miles ahead of the competition. When you're stepping into a job interview or holding a new diploma, showing that you understand these numbers proves you're ready for the shop floor. A lot of beginners out there just load up a program, push the green start button, and guess at how fast the machine should run. But guessing is how you end up breaking a $50 drill bit at 3 in the morning. Knowing how to actually calculate your feed rate, understanding the physical reasons why the machine is doing what it's doing, is what separates a button pusher from a hired professional. If you want to keep building those professional skills, subscribe to Learn and Grow with Fun. We break down manufacturing basics, share career guides, and give you the interview tips you need to succeed every single week.